Okay, can you hear me? Is it on yet? There it goes. Move it up a bit. Okay. I'm glad they put me right after lunch. You can all go get some more cookies. I used to work for a contractor, and we had a contract with NATO, and we would plan to have the most critical part of our presentation directly after they got off the flight, after lunch, and they were all in inebriation or whatever you want to call it, blood sugar loss or extent, and we could get past all the hard stuff. Of course, some of the guys I work for are now in prison. What I wanted to cover, this is not going to be technical like the other ones. It's not going to be research. It's going to be, I'm going to actually look for a lot of responses from you guys about the assumptions we're making about code coverage and our testing and our system testing as the systems get more and more complex. Oh, I need my magic buttons. Okay, first, let's define code coverage, and the real takeaway is the very bottom line. A program with high test coverage measured as a percentage has had more of its source code executed during testing, which suggests it has a lower chance of containing undetected software bugs compared to a program with low test coverage. I have yet to find an actual formal research on whether or not higher percentages of code coverage can be directly attributed to less undiscovered defects. I don't know how you'd even measure that. So it's an assumption to begin with, but it's a good enough metric to go with. Normally, you have tools that do your code coverage for you, and the tools are predominantly based on whatever languages they can make the most money on. So it's C and C++ and Java and things like that. When you get to the Department of Defense definition, most of the tools that you buy online can cover A through E, which is branch coverage and path coverage and things like this. When you get to F, that's where you get to this MCDC coverage that you hear so much about, which is, in essence, it's a greater evaluation of your Boolean expressions or your conditionals throughout your code. And I'll actually have a demonstration of this. Where this is all coming from is we're working in, there is a system I am now working on where you upload range rules into a piece of software that determines whether or not to terminate a flight. So it is software hooked up to explosives that are being determined by an uploadable text file, all right? It's actually being flown. SpaceX is using it consistently. It is intended to be flown on some of the NASA manned missions. And the idea, the basic idea is you draw the rules, and the rules are based on the impact point that the system will extrapolate from wherever it is at that point in time. So it looks at its velocity and direction. It computes the impact point if at that point the engine's failed. And if that impact point is outside one of those range rule boundaries, it starts to count up that it thinks you ought to terminate. And as it gets a persistence count of a certain amount, it will actually recommend termination, and then that recommendation goes into the system that's actually hooked up to, you know, the explosives or the command or whatever. There's no radio, there's no guy with a big red button, it's all on board, okay? When you run these code coverage tools on the system, the interpreter of these rules is getting about 100% code coverage. Looks great. But there is no documentation on the code coverage of the actual rules themselves. So here's kind of what these rules look like. They've got ignition logic, burnout logic, qualification logic, apply when, fire when, and all these conditionals. And over here on this side, this is similar to where the lines would be. There's your boundary situations. And then they have these little lines which slowly move out. And your vehicle's supposed to race ahead of these lines as they fill in behind him with the idea that it's not going to turn around and come back or go straight up. It's got to continue on in a forward motion, okay? If you can imagine all of that data written as if-then-else statements in your C program, you can imagine that you could actually do coverage on that. If you could imagine every lat and longitude point written within the C code, you could actually come up with metrics running these tools. That's not how it's done. It's a text file that's loaded. It's actually a pre-processed text file. There's no coverage tool that can actually instrument that text file because it's not executable. It's just data. What you end up is something like this. Here is a logical condition in here. This is the qualify logic for a particular sensor. And here would be full coverage, all the true falses that you could throw at it. And what you really are going to get to is this is the key, this is what would be considered sufficient testing by the D0178B, where in essence, and if you go to the next one, this is what you would test. It's not just an all true or an all false, which is normally what most of the coverage tools will test. There are very few, if any, tools that will test the idea that the logic of this is when all of them are true, we have a true. When any one of them is false, we have a false. And that's sufficient coverage according to the DoD. Now, if you go back to this, what you're really doing is saying either you've got to do 16 big tests or you can break it down into these set of tests. So now we've reduced the amount of testing that you have to do. So the idea was is if I want to test these rules that are the range safety rules, I would have to test those conditions throughout the range safety rules. The other part of the range safety is you have these Latin long coordinates, and they define boundary conditions and gateways and keep out zones and the finish gate, etc. And what you're looking at is how would you do, what is coverage on this? And if you think about it, most times people think the coverage on this kind of thing is probably a Monte Carlo analysis. You throw a bunch of trajectories at this and you cross the boundaries as many times as you can, and you've covered the behavior you want this system to have. Well, when this was first developed, the range rules, these are the range rules coming in here. It's a text file. It goes into a Cherry tool, which allows you to manually insert drifts into the sensors or dropouts of the sensors, and then that can go into a simulator with the software itself. And to do Monte Carlo on this, this is a manual tool, and you run a trajectory. You set up a manual change, and you run the trajectory. So they were running about 100 simulation runs to test the coverage of that entire system for a termination rule suite, which is not what I would consider coverage with the amount of data points you had to actually cover on this tool. So when they meaning NASA, the U.S. Air Force, and a number of other entities that are involved with this, started working on the next version. So the next version here says, well, we can come in and check our tool out, but we can end up, this routine here will actually put malfunctions into a whole bunch of trajectories, and we run them through a very fast simulator here, and we run them against the software, and we actually end up with something we can analyze. So this right here is an analysis of the Monte Carlo runs where it crossed the boundary and stayed within the boundary, and here's an assessment tool of those runs in terms of what's your likelihood and your risk assessments. This is the kind of tool suite that the Air Force developed, and we're moving this into the NASA arena, and we can get 500K simulators in about 8 hours. So we can run 500K runs. So now we're talking about coverage of the boundary conditions. However, this tool in here with these runs, those runs predominantly are veering off course of a particular trajectory. It doesn't cover all the conditionals that we saw in that previous slide where I can fail certain modes, all true, one of them false. It doesn't have that capability to do that. That still is untested. So in a summary, I can run coverage tools on the actual interpreter, and I get close to 100% coverage. No definition exists that defines boundary coverage. No tool exists that can instrument these range. You can't instrument it the way you can with these other tools. No metrics are reported about boundary segments exercised, meaning when you run the Monte Carlo analysis, you don't get a report back saying where it crossed, what was the state, et cetera, how many different zones did I hit. You get those pictorial runs, and you could probably dig it out, but it still can't do all the conditional problems. And the Monte Carlo doesn't do, this is the conditional, all sensor input conditionals, which are in the tools. I mean, it's in the rule database that you uploaded, but you still haven't tested it. So I've got all these gaps that I had to deal with. And so what I'm working on, and this will be part of what we're going to generally talk about, is I came up with my own coverage definition. So I'm going to use the MCDC type coverage for all the conditionals in one of these data packages. And then I'm going to try to I'm going to influence the unit tests for what I'm going to do is for every lat and long position, I'm going to run a unit test where I exercise just inside and outside that box and see if indeed those units that make determinations as to whether I've crossed a boundary or I'm within a boundary or I'm at a boundary, etc., if there's any issues with those routines. Now, every time you launch from a different location, you set up an entirely different set of rules. It's a different vehicle, it's a different weight, it's got different max and mins, and it's got different boundary conditions. So what the tool suite is going to do is run through those rules and then come up with, here is a list of, in essence, think of it as a checklist. Here is a list of all the tests you should be doing with this set of rules, and are you doing them is the next question I had. Oh, I know. You're doing this to everybody. It's fair. Well, I can keep talking. Okay, there's that guy. Okay, now, this is where I'm going on this, and we have time to open the discussion. If you actually go and take a look at what you are now doing with your code coverage on your tools, and you say, yes, we go through the entire requirements document, and I verify that I've met every single requirement, no doubt about it. Or maybe you go into your state machines that you developed, and you say, I'm testing every single statement transition in there. Or you're saying that the coefficients I uploaded when I did it on the software-only test bed, even though they're different, they're good enough for the day of flight coefficients, even though those coefficients can dramatically affect the behavior of the software on the day of flight. We're dealing with software that's now being written generically or generally so that on day of flight, they tweak everything. 2,000 coefficients go on the load to the vehicle. Those were not the coefficients that you tested on your test bed. Those were not the coefficients that you actually ran some kind of certification or acceptance on. And yet you're flying with these new coefficients that you're saying, it's good enough. And you're thinking that, well, our software had 100% coverage on it. But the coefficients changed the entire behavior of the software. Now, this goes to expert systems, AI. It goes to the automobiles that are driving on the road, running over bicycles. The whole idea of, I'll probably go to the first slide had a quote on there which was saying, take everything you've taken for granted and put a question mark at the end of it and start looking at it again. Are you really doing what you need to do if you think you are doing code coverage? Let me give you some examples. The test mission was on a Falcon 9 and it was scrubbed. It had an autocode script error in the autopilot propellant slosh model affected in the modal frequencies. So they were dealing with the slosh model of the propellant. This was its first use, first flight of this new script. It had not been validated. The slosh model itself had been previously VNV'd, but now that had the wrong inputs. They had to stand down, they detected it, they stood it down, they worked on it, and it actually finished out the countdown. So how many thousands, millions of person hours went into the development of the spacecraft that's on the launch pad, and one coefficient was going to make a bad day. CRS-10, an incorrect value was loaded in the Dragon spacecraft when it was globally positioning. It was approaching the International Space Station. And it detected it, and it had a 24-hour hold. It actually has when they have a failure on mode, it has to reset, kind of like an airline coming back for another landing. The problem was traced to an incorrect data value in the spacecraft's global positioning system, critical to operations as data informs the vehicle of its relative position. The abort resulted in a 24-hour hold around. Now, I looked into this, and it appears that the upload had occurred out of a new Excel spreadsheet tool suite that some operator had decided to build on his own. It hadn't gone through verification and validation, the tool that he was using, and the value was uploaded from that tool suite. Again, we work on all this stuff, and then we change that last coefficient just before launch, and are we really covering our tail on this one? This is the best one. The Russians have these launch sites over here, Vostochny and Baikonur, right? And this is they launched the Meteor M satellite, and it blasted off from this new launch facility at Vostochny, which is over here. Only it was programmed that it was taking off from over here. Okay, and they lost the entire mission. Okay, now first, when I dug into this, I was thinking they uploaded some configuration file somehow and loaded up this guy's configuration file to him. But as I dug into it further, they had used a lot of reuse code from this launch site to this launch site when they built the new launch site. And it appeared that there was some inline code that was written in there that only applied to this particular position in its launch facility that they hadn't caught. So when they reused it, it actually thought it was taken off from over here. I think you guys had enough for lunch. Okay. Okay. I've actually heard this in the hallway. Let's put it in the data load to simplify the software testing. Okay. Okay. Data-driven systems expect the load to differ from the load used during software system verification. It's expected. Okay. Data loads can dramatically alter the software behavior. No doubt about that. You think about fault management loads and things like that. Data loads require some matching of software analysis design verification to allow the system verification for these late changes for the system performance. So you're talking about regression test. You're saying, well, if I change these coefficients, that means I now need to do these regression tests. Now, how many of us do an actual formal analysis of what needs to be regression tests for a particular value? Do you actually look at who uses that value or what is influenced by that value directly, and then what is influenced by that value indirectly, and maybe to the third tier of indirection? Okay, how much of the software do you have to? Most of my experience has been you talk to the engineer and he says, well, we'll test that task again, okay, kind of thing. It's not actually an analysis process. It's a kind of a feeling that that code goes into this module and it should only affect these things, all right? We may be getting to a complexity where that may need to be a little bit more formally resolved. What designs can support analysis and verification of these slides? Would analysis of data formally identify the regression tests? Meaning, there are tools out there now where you can look at dependencies between variables and processes, and call trees, and called from trees, and called to trees, and things like this. And some of that data probably is very valid on what determines what a regression test can be. And are we doing enough is one of the big questions, saying, as software becomes more expensive, much of the software is being written because they want to use data loads so that you can use them on more and more missions, so that you can use them in more and more conditions for launch, so that we're loading these coefficients very late in the game, and then you have to decide, how are we actually verifying that? Are we saying, well, we verified it a year and a half ago on a test bed, it should be okay. And I think that may need to be relooked at. So this is my kind of, I think that's my last slide. Not really. Okay, those are my, I have a slide here that we can all join in on, and mics are open. What kind of systems are you now working on which have these kind of data loads, which you've worked out a perfect solution for everything we've just discussed in terms of how we need to be looking at the software? And like closed-loop systems for tuning, a lot of closed-loop systems have tuning algorithms for your PID and whatever like this. Launch data loads to meet the day of launch environment. SpaceX loads 2,000 plus coefficients into their spacecraft on the day of launch. And right now, the launch services requires them to do regression tests for any of those values that they change. And if the value is in a particular table, they have to regression test the whole table, okay? There is no, I have found no formal documentation that relates those tables to the actual regression tests that they're running, okay? Whether that's completely, but that's what the kind of thing that's going on. What does system verification mean when you're flying it without the coefficients that you're ultimately going to fly? Then you've got autonomous systems with fault management rules, expert system, neural networks. Some of the ideas would be maybe you have to develop tools, which is kind of what I'm doing, is some external tools which are written such that you can verify those coefficients to be usable. Maybe it's an expert system itself. My tool suite is simply going to be pretty simple because I'm just going to look for the conditionals I need to test plus the Latin long coverage that I need to do. And then you end up with reused code and generated code. Generated code is kind of interesting in terms of there are groups right now at NASA that do a lot of generated code, and they make changes and it generates code. And the idea of doing a regression test on generated or regenerated code comes down to can you formally or confidently identify what software has been actually altered when you made that change to your model that actually changed the system code. And they've opted to do no regression tests. They'll do a full system test for all their changes, and they put that in their process because they could not identify whether subtleties were getting into the generated code from the model. Any comments? Oh, lunch did a great job. Okay. Here's some suggestions that I want to finish up with. Define what coverage means. What does coverage mean when your system is got a robot arm on it and it moves around and everything? What's coverage of that particular manipulator? What is the coverage that you're looking for there? So you need to define coverage, whether you're going to cover the unit tests and everything. For example, with this autonomous flight termination system, I would define coverage as I would use tool suite to get the C, C++ code coverage of the actual C code itself. And then I would define coverage of the rules in a different manner using different techniques and a different coverage metric so I could actually call it coverage. You might want to partition your uploads into files, tables, and objects so that they encapsulate the load effects, so that there's a direct relationship between those tables and objects to the regression tests that you would use on those tables and objects, so that you can say, well, this table is got to be this kind of section. And that actually maybe works down the verification. Include configuration upload defects as part of stress testing, not just defects or stressing or overloading the processor in terms of the software itself, but what kind of upload defects might cause stress on the system by screwing up an upload in your configuration. Maybe that's where you can do sensitivity. Now this is a little funny. We all have in our unit test and unit code, we usually have some limits in there that says this value can never be negative, or this value can never be greater than this. What if you were to do a real formal check and bring those unit checks down to something that says this value should never be greater than 1.17235 according to the GNC guys, okay? What I'm saying is maybe you err on the side of getting critical false positives, but you will get the critical negatives that you want if a coefficient is actually going to affect something in a negative manner. If you change a coefficient and it breaches that limit that GNC says it should never go above this limit, then your code is telling you there's something wrong before you go fly it. I mean, you tighten down your margins, you're going to get more false positives, but you're going to catch maybe that critical issue that said it should never go above this, okay? And then this is the kind of stuff I'm looking at. Maybe we have to build and deliver some utilities to do some of this verification testing along with the software. The idea that let's put it in the configuration file so we don't have to do so much work on testing goes to, well, then you better do work elsewhere to get that same coverage so you can still meet the requirements of whether or not the coefficients actually affect your software. I think that's the end of the game here. So I'm very interested in hearing whether or not this rings true, whether I'm completely off base. I walked through some of the rules. Yeah, we have a... Yeah.
What was that comment?
Just because it's... Oh, sorry. I'm from the Aerospace Corporation. We've been arguing about this with contractors forever. Just because something's in a table does not mean it's not software.
Yeah, to add to that, when I go through the reviews for this entire flight termination system, they're worried about the hardware the initiator, the sensor inputs, and the software itself, there is nothing written in their concerns about the rule database itself. That's a given, okay? And I'm arguing that it causes such critical behavior changes in the software that it has to be treated at the same criticality of the software.
So I have a question about the neural network coefficients.
Okay.
The
Yeah,
way, slide back right there. So the way those coefficients are derived, I don't think we know how they are derived.
That's true.
So,
we don't even know what they are, and now we're uploading them.
Yeah. So I don't know where we are going to go with that.
No, I don't. It's obvious with the cars driving around and trying to be driverless that they have no idea how to test it formally either, because they've got to put it in a environment where they're doing empirical testing. So I don't know that stuff. In fact, I was very concerned when I looked at the AFTS that it was an expert system, that it was going to have chaining and back and forward and things like this. It's a very simple implementation that could have been done in C code straight away, but it needs to be flexible to upload. There's a reason for that. But there's got to be a way to test it. I don't know. You know what's funny? All those things with neural networks and expert systems, whatever, they all found application where there wasn't a criticality. They're all in the stock market. They're all in something else. That if it goes wrong, that's okay, but it's not going to land on an elementary school.
Yeah, we've been doing a project for a couple of years to look at a whole bunch of these different programming techniques and work out V&V methods for them. We did some of the first V&V methods for expert systems about 30 years ago.
Yeah.
And neural nets are especially opaque. And there's a whole field now of explainable AI, which is trying to solve that problem after the fact instead of a priori. But we're trying to put together a series of guidelines and rules about what sorts of things can you do with these different kinds of software in order to at least get some confidence that they'll work.
Yep, I agree. I'm saying, what is the V&V for these just sitting on your desktop before we start to apply it to the entire system and mission? Yeah. Hey, it worked. Worked on those. It found my family faces in all my photos.
Go to your next slide. I just had a couple comments to kind of turn your second point around kind of backwards is when you're designing your tests and designing your parameters for your test, what we will typically do is try to figure out the test to go through those downstream impacts. Now, that's not very, very scalable when you get to thousands of parameters and scripted rules and things like that, but that's a process that we've used. And this also just kind of brings up you talking about unintended downstream consequences of parameters. You might want to consider borrowing some techniques from the cybersecurity world. When we did some cybersecurity looks at our code earlier, a couple of years ago, they recommended a technique they called fuzzing, where they take the expected output and just kind of move it around a little bit. And they recommended we do that with our parameters just to see what unintended consequences we have on our code. So those are two.
I think that'd be great. Yeah.
Just had one minor comment on my group at JSE that I work with, the robotics group. In ER4, we recently, well, I say recently, probably the last 6 months or so, we've started doing a lot more code coverage, and it's just a general encouragement to people who aren't doing it that it can really paradigm shift your group and how you design your software, because a lot of our developers really get into writing our unit tests first and everything before we ever write a single line of code. And we've had a lot of redesign of various pieces of software just based on code coverage and unit test analysis. It can really, change your world.
I agree. And actually, when I looked into code coverage years ago, I was at JPL, and I was with a very small group, and he says, one of our experiences was we all assumed we had really good code coverage. We weren't doing a metric, but we were doing a really good job, right? And then he said, well, let's run code coverage. It's a small enough group. Let's put it in. And they were in the 70s. And it really enlightened them they thought they were doing that kind of code coverage. But along those lines, again, you can get that 100% code coverage, but you're not covering some of the things that are going to bite you later on because they don't go through that tool.
Thanks. Hi. So I do integration and unit testing for Lockheed Martin. So I really like this topic, first of all. We use a code coverage tool called LDRA to do our unit test and stuff like that. So I was wondering if you had any additional ideas or like tool suggestions for code coverage, because there's kind of some, nuances with LDRA, and we're looking for more tools as we go forward.
There is, first of all, LDRA is a great tool. The whole suite that they have is really well integrated. The commercial tools, most people don't get their hands on them because they are expensive as like our meal that we had, okay? And so NASA is fighting right now to try to put some of these tools on portals so that people can do scanning and whatever as a license and for the entire agency. And we've gotten some license agreements trying to get that to work. There are open source tools that are being worked. And actually some of the work I did when I did some work with the Toyota acceleration, we built our own tools, just from grep and some other Perl type scripts just to find whether or not enables and disables were matched and things like this. So there's some tools you can actually work on. I don't have any, the only comment I would make, not so much on code coverage, that seems to be pretty legit, although I will comment that I don't know of any tool that does the MCDC type definition of code coverage. But when you're dealing with other things, static analysis, we have found that multiple static analysis tools will come up with almost completely separate results because they use a completely different paradigm or a heuristic in their code coverage, not code coverage, in their analysis. So that might be something to look at.
Okay, thank you very much.
You bet.